Don't be nervous. All right. Okay. Tell me what you know about quadratics. Have you heard that word before? I hope you've at least heard that word.
I have no idea what it is.
Heard it, don't know what it is.
I think of quadrilateral.
You think of quadrilateral, you're regressing to geometry. Quadratic formula, we're going to do that in this chapter, absolutely.
Quad means 4.
Quad means 4.
So it's 4 squares.
Tell me who taught you quadratic formula? Where'd you learn that?
Owen Dad.
I'm going to guess from their video.
When I
Did you? Now what are you going to do for yours this semester? Okay.
Wait, I think I remember listening.
Me and Free did that.
All right, so we've heard quadratics. We're not real sure what they are. So a quadratic is an equation that has an exponent of 2 on the x, okay? A, B, and C are coefficients. So you've graphed lines before, right? What's the form you're most familiar with lines? Slope-intercept, mx plus b. And just like when you're in slope-intercept and that m and that b are in there, those are just variables that change, right? Same thing with the a, the b, and the c. Okay, so if you see that exponent of 2 and that's the biggest exponent in there, that clues us in that that's a quadratic. So we're going to start out by graphing quadratics. Everybody's favorite, graphing. You got a question? Okay. And then we'll start really working with the quadratics algebraically, okay? So my next question to you is, what does a quadratic look like when you graph it? Does anybody know? It is. Do you know what that thing is called? A parabola. A parabola.
Yes, I was closest.
Okay. It's a parabola. And so a lot of you are doing it with your fingers. It's up or it's down. And you are absolutely correct. And so we're going to talk about some features of a parabola before we actually graph it. Looking at those two parabolas, one of them is down and one of them is up. Tell me some things you notice. One's down, one's up. It's curved.
Semi-oval.
It's what?
Semi-oval.
What does that mean?
Semi-oval.
Semi-oval. Okay. I don't know that that's a word, but we'll take it. What else? Think geometrically. What do you notice? Somebody said it's symmetric. It is symmetric. That's a big one. It's symmetric. So if it's symmetric, then it must have a what? What? A line of symmetry. That's exactly right. A line of symmetry. So this line of symmetry in a parabola we call the axis of symmetry. So far, so good? Yes, Miss McGee.
No, Miss McGee.
You got to talk to me. It's easy now.
Yes.
Okay. Okay. So, we know that it's symmetric. We know it opens up or down. It's semi-oval. What else do we know? Well, but you wouldn't graph both of them. These are two different graphs. So, what else?
The endpoints are the same. Like
okay, so it either both ends both go down or both go up, right? Do you notice that these are what we call bounded? In other words, it's not going past a certain point one way. Here, this would be the highest point, right? And here, this would be the lowest point ever on the graph. And so you may not be used to graphing things like that are bounded. Lines go on forever in both directions, but these are what we call bounded. They have a high and a low. This point is probably the most important point on the parabola. It is called, does anybody know what it's called before I tell you? Starts with a V. Somebody, yeah. Vertex. It's the vertex. All right, it is the vertex, okay? It is the highest or the lowest point on, and I've got two going here, but you all realize these are two different graphs, right? Okay. So, speaking along those lines, we can look at the equation. Remember that equation was y equals, let me change the size here. Ax squared plus bx plus c. Are you having trouble seeing? Can you see okay? Okay. Can everybody see where you're sitting? Okay. This a in front tells us whether the graph opens up or down. Okay? If A is positive, then the graph opens up. But guess what happens if it's negative? It opens down. So this first graph, A is negative. Right? Less than 0 means it's negative. And the second graph, A is positive. Does that make sense to everybody? Yes, Ms. McGee. Some of you are shaking your head. Okay, thank you. Let's see what else I can take. Oh, A does something else really cool. Y'all got this? Can I go to the next slide? I'll wait if you need me to. If y'all see me forget to hit record again, a lot of times I'll pause and let you catch up so there's not dead air on the video. All right, so we said A, up or down, positive up, negative down. A also tells us something else. Now, we're not looking at positive or negative because that determines which way it goes, up or down. We're going to look at how big or small A gets. So as I'm talking about getting smaller, I'm really talking about what? But if I say not including negatives, as A gets smaller, then I'm approaching what? 0. So I'm getting closer to 0. So I'm talking about fractions and decimals, right? Okay. So the smaller A gets, and I'm going to say the absolute value of A, if my pen will let me. Come on. Absolute value of A. As it gets smaller, so we're talking fractions. I'm going to say less than 1. Okay? As A drops down below 1 and gets closer and closer to 0, it makes the graph open up. It makes it wider. Okay, so if A was 1/8, then the graph is going to be really wide, okay, which is the opposite of what you would think. You would think that the smaller it gets, the smaller the graph gets, but it does the opposite, so you have to remember that. Now, 1 is what we call a parent graph. So I say that's an average width, okay? That's where I started the vertex, and it's going to go up 1 over 1 on each side. That's an average width parabola. That's a parent graph, okay? Now, as A gets bigger, or the absolute value of A gets bigger, what do you think happens to the graph? It gets skinnier and skinnier. So if I had y equals 10x squared, that's going to be a parabola that opens up and is really skinny. Are we all okay thus far? Yes.
The lower one is the wider.
Correct. And we're comparing it to 1. We're using 1 as what we compare to. That's our average, our normal. One other thing on the equation before we look, and that's the C. Anybody take a guess as to what C is?
The vertex point, Y-Intercept.
Yes, Y. Do you know why, or are you just guessing?
I'm just guessing.
Okay. How do you find an intercept? What is an intercept, first of all? Where it touches the axis. So if I'm looking for a Y-intercept, how do I find that based on the equation? Something happens special with x at the y-intercept. What is it? It's 0. So if you plug a 0 in for all the x's, it would solve it, you'd get your y-intercept, right? Well, if I plug a 0 in here, anything times 0 is 0. Anything times 0 is 0. I'd just be left with c. Okay? Same concept when you're in slope-intercept form. That's why the b is the intercept. Okay? So the c on the end is where it crosses the y-axis. Everybody good with that? Let me give you a couple examples and see if you really are good. As I write these, what happens if a term is missing, like the middle term? What does that mean? It's a 0. It's a 0. All right, so I'll give you just a second to copy those down, then we'll talk about them. The first one. Is it up or is it down? I hear both. Which one is it? Why? It's positive. That first number is positive, so that tells me right off the bat it's going to open up, right? I should probably change this color here. Tell me, is it skinny, is it wide, or is it average? Wide. Why? Wide-ish. It's a fraction. It's getting less than 1, so it's wider than average. Okay. What else can you tell me? Anything? 5 is the y-intercept. So we haven't even graphed anything yet, but you can tell a lot about this graph based on the equation. Do you agree?
C.
Okay. Look at the second one. Down, why? Negative. Skinny, wide, or average?
Wide. It's less than
You're looking at if it's less than 1, then we're talking wider, and if it's bigger. But it's absolute value. 1 is average. 1's what you're comparing to. 1's the parent. So skinny, wide, or average? Skinny. It's skinny. Because the negative only impacts whether it's up or down. It doesn't impact the width of the graph. What else? Negative 3 is the y-intercept. Good job, guys. How about the last one? Up or down? Up. Skinnier than average, wider than average, or average?
Wait, no, because it's more than 1.
It's more than 1. That's actually 2.5, so it's skinnier than average. I tried to throw you off there. How about the y-intercept?
0.
It's 0. Good job. Everybody okay? Y'all ready to jump into graphing? Yay! Also realize if this was just x squared, what is your a there? 1, right? So it's average and it's up. B and C there are 0. Okay? All right. Maybe I should have made you identify A, B, and C. Can y'all do? Let me make sure you can do that. Look at the first one. What's A? And B? And C. How about the second one? What's A? How about B?
0.
Oh, yeah. And C? How about A?
5.
2.
B?
4.
Oh, God.
And C? All right. Just so that'll really help you if you can identify them easily as we go through graphing. Okay? I know y'all are going to make Miss Wilson proud because you're going to be able to reflect points, right? Over an axis of symmetry. No diagonal lines, just vertical lines. You can reflect a point over a vertical line, right? Okay. All right. I'm going to give you a step chart. On the left, I'm going to do it in variable form, and on the right, I'll run an example beside it so you can have it. We're going to graph. If you want graph paper, I don't require it. It's up to you. We'll call this how to graph in, there's actually 3 different forms. The one we've been looking at is standard form. You know how when you graph lines, you've got slope intercept, standard form, and point slope? Yes, Ms. McGee. Well, with quadratics, we have 3 different forms also. So we're just looking at the first form today. Standard. ax squared plus bx plus c. All right. We'll do steps on this side. We'll do an example on this side. Let's see what we should do for our first one. I'm just kidding. Okay. All right, first thing we're going to do is we are going to identify the axis of symmetry. I'm in a room. Now, the axis of symmetry, remember, was important because, one, it divided the parabola, but what else happened through the axis of symmetry? That vertex sits on the axis of symmetry, so it's very, very, very important. So I'm going to give you a little formula to find the axis of symmetry. It's a vertical line, so vertical lines are in the form what? What's the equation? X equals a number, right? So I have, my pen won't work. X equals opposite B, even though I wrote negative B, I want you to think opposite B over 2A. Okay, because it's a vertical line, remember it's in the form X equals. So if I come over here to my equation, well, before I start, tell me what is A? 2. How about B?
6.
How about C?
3.
Tell me what you know before I graph it. Just quickly. It's positive, so it's up.
It's skinny.
It's going to be a little skinnier than normal. 3 is the Y-intercept. Here again. We're not allowed. So I am. Okay. So let's do this one. Let's do the axis of symmetry, X equals. So if B is 6, then opposite B would be? Oh, y'all are so smart. -6.
Negative.
Over 2 times A is? Oh, what a horrible first example. It's okay. -6 over 4, which is?
A number. 3 over 2.
Oh, -1.5. That is my axis of symmetry. It'd be nice if it was a nice whole number, but
Would you rather us write it as the mixed number?
Fractions. Always fractions. Fractions are fun.
No.
I loathe fractions.
All right, y'all have your calculators, right? Okay.
No.
Axis of symmetry. -3 over 2 is -1.5, so I just went over -1.5 and drew my axis of symmetry. If you have graph paper, your graph will look a whole lot nicer than mine. Okay. yes, I did. Okay. All right, so we've got our axis of symmetry, so now we need to find our vertex. So tell me this, if you have an x value, how do you find the corresponding y value so that you can plot that particular point? If you have an x value, okay, you've got an x coordinate, you need the y coordinate. How do you find that? You have an equation. You plug it in for the x's. That's exactly right. You plug it in for the x's. We're going to plug in to our equation. Okay? It says y equals, so to find out what y is when x is -3 over 2, I'm going to plug in for the x's. All right, so here we go. 2 times. This is where you will really want your calculator. Now, because I have this fancy calculator, I'm going to use it. All right.
Thanks, guys.
Just in case you don't know how to input things on your calculator, I'm going to show you. Fractions always go in parentheses. So, and even if you have a scientific one, this will work. All right, I'm going to do it all at one time. Negative 3 over 2 squared. Nope. Squared. Plus. Now, because I'm doing multiple things here, I'm doing 6 times a fraction. I'm going to put some parentheses around this middle term. 6 times negative 3 over 2. If it makes you feel better, you can definitely do this in parts. You can do the first term, the second term, and the third, and then add all 3 together. Yeah, because I did a parenthesis around the fraction, and then around the whole term itself. So essentially, I did this. I wanted to put a parenthesis around the middle term there. Do what? Brackets?
Stop it, Taggart.
You can. Same. It's still a grouping symbol. All right. I'm going to hit enter. I get negative 1.5. We know that that is negative 3 over 2, but just in case you did not know that your calculator will put it back as a fraction for you. If you hit math, enter, we'll put whatever answer you have back as a fraction. It's pretty nice, right?
That is cool. I thought there was another button.
Math, enter.
Look, you click math until it
The scientific calculators will do the same. They have a button that says F to D, which is fraction to decimal or vice versa. It looks kind of like this. That'll take it from a fraction to a decimal.
Yeah, I think that's what it's like the thing like F arrow.
Was it negative? All right, anybody confused so far? All we did was plug in, okay? And I'm taking a long time about doing this because I'm explaining this. This is the first time you've seen this graph, so don't be intimidated. All right, I'm going to come over here and plot because I know now this means that the coordinates of my vertex are negative 3 over 2, because that's the x part, and the y part then is negative 3 over 2 also. Everybody sees where that came from? Negative 3 over 2, negative 3 over 2. So negative 1.5, negative 1.5. I am going to flip over. It's thinking about it. All right, so I got negative 1.5, and then I'm going to go down negative 1.5. Stop me if you're confused.
Okay, I worked down.
All right. I only need 3 points to graph a parabola. I need the vertex, in this class anyway. I need the vertex, and I need 2 other points so I can see how it widens and how it goes. So I need to pick, I'm going to call it an easy point. Now, this graph is nice because one easy point on here is something that you already identified. What did you identify in the original equation as a point on the graph?
The Y-intercept.
The Y-intercept, okay? That would be super duper easy to use, and you most definitely may use that. You may use x equals 0 and find the Y-intercept. You do not have to use that. If the vertex sits there, you can't use it. Okay, so I want to show you what we do if we can't use it also. So what I'm going to do is I'm going to look at where I am on my vertex. Now remember, these graphs go up really fast or down really fast. So if I'm at my vertex here, and this is, say, 1, 0, I don't want to pick 5 because 5 is going to be way down here. My point's going to be so high I'm not going to be able to graph it. So I want to stick close to the vertex. So if I'm at negative 1.5, what's a close point there to the vertex? Negative 1. I would choose negative 1 here. Of course, if I was doing this, I would choose 0 because the y-intercept's very easy here. But just for the sake of example, I'm going to choose 1. I put that in the wrong place. I should put x equals negative 1 here. Here I should say x equals close to vertex. And again, to find the y that goes with that, what do I do? Plug x in to find y. That's right. So now I have y equals 2 times negative 1 squared, 6 times negative 1. And I hope you don't need a calculator for this one. Negative 1 squared is a positive 1, and 2 times 1 is 2. Minus 6 plus 3. Bless you. Negative 4 plus 3 is negative 1. So another point in the graph. Negative 1, negative 1. Are we all in agreement? So let's plot it. Do I need to stay here a second? Negative 1, negative 1. I'm going to put a little V, even though it's going through the axis of symmetry. I want to keep straight that that one's the vertex, not the other one. And now's the easy part. Now's the fun part. If this parabola is symmetric and I have one point, can you find the third point?
Yes.
How? Just reflect it over that axis of symmetry. So the very last step, I call reflect and connect. I came up with that all by myself too. I will probably say some of the dumbest things that help you remember, because that's how I remember stuff. It's quirky little silly things.
Oh.
Connect. Reflect and connect. All right. If I reflect this point, it's contagious. I go over a half, right? So I'm going to go over a half more here. And then connect it, make the parabola. Don't make it a V, because it doesn't V. It's a nice smooth graph.
So it goes like, it doesn't go.
Okay.
Question.
You have so many questions? What questions do you have?
So,
I have to figure out how to word them.
Okay.
So it doesn't go like straight and then curve. It goes like.
It's continually inching its way out.
Oh, okay.
But it's ever so slightly that it's moving out as
So,
it
like,
gets further up.
It wouldn't be like that.
No, it's going to, I mean, I get what you're saying, but no, it's going to keep moving outward, but not at a great rate. And it may help you. Remember we talked about that Y-intercept? What was that Y-intercept? 3?
3.
1, 2, 3. If that's the Y-intercept, I can reflect that over 1.5, a half, 1. And you can kind of see how it's working its way out slightly. And it would have been perfectly acceptable to use these 2 points up here, just as acceptable as it is to use the bottom 2. I just find it easier if I stick close to the vertex. Other questions? Yeah.
So, like, the choosing the point, the easy point, it doesn't really matter
Nope.
what it is as long as it's somewhat close.
Yeah, and it doesn't even have to be close. It's just easier for you if it's close. Had I picked 3 for this one, well, if you plug 3 in, you're going to get a really, really high number. I don't know what it would be. 2 times 3 squared, 6 times 3 is 18, plus 3. If you plug in 3, you get 39. Well, 339 is a really big point to plot. So the further I get away from the vertex, the bigger the number's getting. Or smaller, depending on if it's up or down. Does it meet the criteria that we talked about the first time as far as skinny, wide, up, down, Y-intercept? It does. So it's a good check.
So that's good. We'll go out and make it 1, 2.
No, that's fine.
So the other.
Yeah. Yeah, I'm looking at your graph, but I'm looking at all your work, too. That's really what I'm looking at. Other questions? One more start finish?
Wait,
It won't take that long, I promise.
So
that was
say-
just because I was
say your number's
introducing
not
it.
like 1.5. Say, I mean 3 or maybe 3 or 4. Say it was like 9.
Mm-hmm.
Then would you do the closest number be like 10?
Yes.
Or 8?
Yep.
So it would still make like a super big
Correct,
number.
correct. Hopefully. Depends on your equation. But if you got a fraction in front, I mean, you could have fractions all through it.
No, I'm saying like
But-
it would make like a huge number though.
Oh, no, not as long as it's close to the vertex, you're good. What else? Ask away. Yes, sir.
Like the, is it called the quadratic? 2x squared? Since that's a 2, so that is skinnier than an average one.
Yes, because this one goes over a half and up 1. An average one would go over 1 and would go up 1. So it would be wider, a little bit wider. My graph is not very accurate because I'm doing my own little dashes. I should put graph paper up here so you can see. And it's not, I mean, it's not by much, but it is by some. Other questions? Y'all sure? This vertex that sits on here, would you say that that's a maximum or a minimum?
Minimum.
Why?
Because it's the lowest point.
It's a low point. Does everybody see that? That's a low point. It doesn't go below that. So I would call that a minimum. So some questions may ask you, what is the minimum of this quadratic? Well, the minimum is just the vertex. So the minimum of this would be negative 3 over 2, negative 3 over 2.
So what graph is going down?
It would be a maximum, exactly. What else? Ask away. I'm going to do one more, but tell me what you think so far. Pretty easy.
Yes, this with the maximum overview, you just say infinite.
There is no maximum on this one. It doesn't have a maximum. All right, let's do this one together. Let's do 3x squared minus 18x plus 20. Tell me before we start, is it going to be up or down? Skinnier, wide, or average? Skinnier than average. What's the Y-intercept? Uh-oh. So I might not want to use the Y-intercept for this one. That's pretty high, right? I don't know. We'll see where the vertex is and see what happens. What's A? What's B? What's C? What do I do first? Find the vertex, the axis of symmetry, which the vertex is on. All right, so axis of symmetry. How do I find that?
X equals opposite B.
Opposite B over 2A. What is B?
-18.
So what's opposite B?
Positive.
Positive 18 over 2. What's A? 3. So 18 over 6 is 3. Good job. Were we going too fast? Everybody okay? I have my axis of symmetry. It is graphed. Now I need my vertex. How do I find my vertex from my axis of symmetry? You plug it in. 3 times 3 squared minus 18 times 3 plus 20. 27 minus 54. If I'm wrong, y'all tell me, because I don't have a calculator. Is it -7? So the coordinates then of my vertex are 3, -7.
Is this supposed to be plus something or minus?
Minus.
Oh, why is it? Oh, wait, shoot.
Yeah, I'm going to pause it here. Should I use the Y-intercept here?
No.
Oh, goodness, no. I'm down at -7 to take it up to 20. Oh, my goodness. So what should I use?
2 -6.
Maybe 2? If I plug 2 in, what do you get?
Wait, you're trying to get 2 close to what? 3?
Yeah, I'm trying to get as close as I can to this value, the x part of the vertex. All right, 3 times 4 is 12. Make sure you're squaring before you're multiplying. Remember your order of operations here. So it's 2 squared and then times 3. Minus 36 plus 2. 12 minus 36 is negative 24, plus 2 is negative, ooh. Oh, I was going, oh my gosh, there is no way that should be, okay. So now negative 24 plus 20 would be negative 4. Thank you. It's like I'm losing my mind. All right, so the coordinates of that point, 2, negative 4. Much better than 0, 20, right? Or 2, negative 20, whatever I was fixing to do. 1, 2, 1, 2, 3, 4. This one you can tell the skinny in it, right? You can tell it's shrunken. All right, reflect. So over 1, and connect. We will most definitely save domain and range for tomorrow. Bring your big boy and girl panties tomorrow, though. Just to make sure. You want to do it today? I don't know. We don't have time today. Domain and range is kind of loaded. Because although technically you should know domain and range, nobody ever does. Nobody knows domain and range.
The range is like the one that...
I don't remember.
That's like a chart.
Range is wide. Oh, no. It's
different in graphing.
yeah.
I was thinking of you.
Domain is all the X values, range is all the Y values, but, I mean, there's a lot because it goes on forever. So. Let me show you this quickly because this will come up on your homework also. If you have something like this that you're asked to graph, what is A here?
5.
What's B?
0.
And what is C?
0.
So what's your axis of symmetry? 0. So the y-axis is actually your axis of symmetry. So if you have x equals opposite b over 2, it doesn't matter what's down here because it's 0, right? So this is your axis of symmetry. So when you do your easy point, you're still going to plug in, but you're going to have to use 1. You have to go over because the y-intercept and the vertex are going to be the same in problems like this. Does that make sense? I don't know why the easier ones like that always stump students. I guess because I start with the harder ones, and then you see an easy one and you go, what? All right, so here the axis of symmetry is 0, right?
Yeah.
So if I plug that back in, I get 0. So my vertex is 0, 0.
So is it
For my easy point,
just use 1?
I'd use 1 and get 5.
Super steep.
See how quick they can go once you get the hang of them? They're really not, it's just, yeah, no, write down, that's fine. And this is kind of curved here. On